Okay, today is our last section before our quiz and test, and we're going to talk about scatter plots and regression lines. So first off, I know that you've covered this before, so hopefully this should be just a quick review, but a scatter plot is a set of points representing data. The line that best fits a set of points is called we're going to call it a regression line. And what I want you to write on your paper over to the side here, you have room, I don't have room. It can also be called a line of best fit or a trend line. And I want you to write both of those names down there. So um, you'll know that any of those names can refer to the same thing. And a measure that is used to describe the strength and direction of a relationship between the variables whose data points lie on or near a line is called the correlation coefficient. Basically, like I said, it's a measure describing the strength and direction of your regression line. That's what this is just defining again as your regression line. It's denoted with the letter R, and excuse me, it goes between -1 and 1. So here are some pictures of what, excuse me, data may look like when we plot it. This first one, R would be equal to 1. Here, they would say R is about 0.8. This one would be your R value equaling about 0.3. This one, R would be equal to 0. This one, our R would be negative zero point 0.3. This one would be a negative zero point 0.8. And this would be a negative 1. So what does this tell us about each of them? If you have R equal to 1, then we say that we have a perfect positive correlation. If R is 0.8, then we say that we have a strong positive correlation. If I say that R is 0.3, then basically that's what they refer to as a moderate to weak, but it's still positive correlation. If R is 0, then there is no correlation. So then we have a negative zero point 0.3, and a negative zero point 0.3 would be your moderate to weak negative correlation. R equal to negative zero point 0.8 would be a strong negative correlation. And then R equal to negative 1 would be what they call a perfect negative correlation. But one of the things to notice about this, as you're fixing to have a problem to ask you, is as as x gets larger, y gets larger. That means it's positive if they're both getting larger. Over here, as x gets larger, y is getting smaller, so that's when we're going to have a negative. So these three would be negative, and those would be positive. So look at the question that we have here. Variable x is the number of students trained on new projects, and variable y is the number of calls to other institute. You suspect that more training reduces the number of calls. So more training is our x. So as x gets larger, you're saying that y gets smaller. So is that a positive or negative correlation? And if you need to think about the dots, then it's doing something like that. So we would say this is an example of a negative correlation. These correlation numbers, we're not going to calculate them. They're best done. It is a very lengthy process by hand, and it's done with certain calculators will calculate it for you, but I did want you to be aware of it in case you are asked questions about it. Okay, so you're going to get some data this one happens to be the years of education that you have and then your score on a prejudice test. Um, so what we're going to do, the table lists the scores on the prejudice test with the number of years of education. Make a scatter plot of this data. So the first thing I'm going to do, as I labeled it for you, years of education is your X, score on the prejudice test is your Y. So if I go out 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I'm going to go up 1. Okay, I'm going to pause and finish this, and I want you to finish, and then we will come back together. Okay, so I plotted all the points. It's asking the next question. Oh, actually, it says draw the line of best fit. Okay, so when you draw this line, okay, you need to use a straight edge every time you draw it. Um, the other thing that you need to make sure of is you want to try to find the line of best fit. You want to try to draw that line such that you have the same number of points above and below your line. So I'm actually going to have to adjust mine a bit. Come down maybe. Um, Something like that. Let's see. So I'm looking 1, 2, 3, 4, 1, 2, 3, 4 because these two are kind of on my line if I need to move them a little bit. But that's a line of best fit. That's the one that we're going to work with today. The question says what type of correlation. Okay, this, you don't know the R value, so the only thing that you can tell me is that it is a negative, and actually looks pretty strong negative. So we'll say strong negative correlation, because it looks more like what that picture had. Now, I have the wrong value on here, so I need to change that real quick. And so we continue. We have the points. Calculate the slope of the line through the points 10, 1, and that's not correct. Give me 1 second. Okay, one last time. We're going to go through the points 110, which is right here, and 15, 1, which is right here. So what I'm doing, when you pick these 2 points, first of all, it's very important that you tell me what these 2 points are. So you write those on your paper. Okay, I'm actually telling you this time, but when you have to do it by yourself, you need to write down these points. You're finding points that are on your line. They may not necessarily be in your data, and that's fine. But we're trying to write the equation of this line that approximates our data. So it says calculate the slope. So that will be, remember we connect the y's on top and we connect the x's on the bottom. So that's 10 minus 1 over 1 minus 15. And so that gives me 9 over negative 14. So that is the slope. Now I have to write the equation of the line, and that's what you worked on the last time on the first part of this section. So we're using our equation y minus y sub 1 equals m times x minus x sub 1. And we're going to plug in y minus, you can use either one, I'm just going to use 10. Y minus 10 equals negative 9/14 times x minus 1. And if I continue that, let me go over here. It's y minus 10 equals negative 9/14 x plus 9/14. And if I add 10 to both sides, then my equation, we always write this equation of our trend line or line of best fit, it's always in slope-intercept form. So you start off with point slope, but you've got to end up solving for y. So y equals negative 9/14 x plus, I'm just going to write it as 10 and 9/14 because 10 plus that equals that. So there is my equation for the line, my regression line or line of best fit or trend line that I've drawn. Now, predict the test score for a person with 2 and 9 years of education. So a person with 2 years, a person with 9 years. So you're going to take that equation, y equals negative 9 fourteenths times 2 plus 10 and 9 fourteenths. Actually, I wanted to put that in a different, whoops, too big. Anyway, uh, that's my 2 because I'm plugging in for x. Okay, and when you plug that in and you solve it, you will find out that y equals 9 and 5 fourteenths. Okay, to answer the question, okay, they don't get that kind of score. If you notice, all our scores were whole numbers, so we're going to round that to the nearest whole number. So this person's score would be approximately a 9. Okay, if I did the one with 9 years of education, then I would have y equals negative 9 fourteenths. I'm going to plug in using the same equation, and this time instead of 2, I'm plugging in 9. So y equals, when you plug that in, you're going to get 4 and 6 sevenths. So when you round that, that would be about a 5. So that person would most likely, and it's a prediction. And the last thing you need to know, that when you use one, you need to know the difference between extrapolation and interpolation. Our data, if you look at our x values, our data goes between 4 and 16. So when they asked us to predict, 2 is outside of our data between 4 and 16. So this particular prediction is called extrapolation. 5 is in between, so let's just let you know that your X data is going, as we said, between 4 and 16. 2 is not between those numbers, so it's extrapolation. 9 is between those numbers, so this is called interpolation. And again, you should have had those words before, but you'll have to be able to answer that when you do your classwork worksheet. So let me know if you have any questions, and I will help you.